Okay, so let's continue with video 2. Alright, so it says an instructor holds a safety rope at point C for a student to rappel from the anchor point T. The rope between them currently measures 61 feet. How much more rope should the instructor let out so that the student can make it to a resting point at point R? Okay, so again, I think the idea is, and you have to kind of interpret it, is that they want what T to R is, right? Because I guess this person, he needs to come down to R. And if he's got to come down to R, that means she has to give him more rope, because I think there's a pulley involved somewhere, right? So he has to have a little more slack to get down to R. So we're looking for T to R. Now in this picture, we have two right triangles, right? RCH and TCH. Those are right triangles because of the right angle at R. But then we also have a non-right triangle, TRC. And really, TR, I know it's a part of the bigger right triangle, but it's a side of the non-right triangle. So I think we should focus on that if we can. So let's focus on the non-right triangle in this problem and see if we have enough information to find TR directly. So this is going to be a non-right triangle problem. Again, I'm going to focus on triangle CTR. Okay? So in triangle CTR, which I'm going to draw right here. Okay, so here's C, here's R, and here's T. So I know that this length T to C is 61 feet. I know I want to find TR. So I need a couple more measurements. Well, first off, it'd be nice to have some angles. Well, I can find some angles, right? If you look here, I can find this angle right there because I have, 79 that goes all the way across both right triangles, and then 75, which is in the inside right triangle. So to find this angle, just do 79 minus 75, and that's going to be 4 degrees. That's what they call Y. So that is 4 degrees. So great. So I have a side, I have an angle. Okay. I also believe I can find this angle right here. Okay. And the way I'm going to do that is the following, right? This angle is angle X, they call it, is going to be supplementary to this angle right here. I can find that angle because it's inside a right triangle. They tell me that this angle is 75. This is 90. I know that in a right triangle, these two acute angles are complementary. So do 90 minus 75, that's 15. This angle right here is 15 degrees. So the angle I'm looking for, this one right here, is going to be supplementary to 15. 180 minus 15, that's 165. And I now know this angle is 165 degrees. And now I have the situation of angle. Let me use a different color. Angle, angle, side. And angle, angle, side is a law of sines situation. So I should be able to use the law of sines to figure out my unknown side X. Let's use the lowercase letters, right? So if this is angle C, then X is actually side C. If this is uppercase R, then 61 is side R. And if that angle up top is T, then this side's side T. So right now, I know angle C, I know angle R, and I know side R. I need to find side C. This is great. I just have to use the R's and the C's. So sine of C over C equals sine of R over R. Awesome. So that's sine of 4 degrees over X equals sine of 165 degrees over 61. Cross multiply X sine of 165 degrees equals 61 sine of 4 degrees. Divide both by the sine of 165, divide by the sine of 165, and we're going to type that into Desmos to get our value of X, the extra rope needed for me to get down to that point R. So 61 sine of 4 over sine of 165. So here it comes. So make sure I'm in degree mode. I am. I open up a fraction first. 61 sine of 4 over sine of 165. And I get 16.44, so let's just round to 16.4. So they need, or they just said round to the nearest They just round to the nearest whole number, so 16. So we need 16 more feet, and that'd be our final answer. If we get 16 more feet, he can then go down to point R. Cool. So again, if you notice what I did first, right, is I took a look at the picture, and I said, okay, what am I looking for, right, which is an interpretation, right? I don't know if I quite knew it was TR I'm looking for, but again, how much more rope, how to get from where T is to R is, I mean, it kind of, makes sense, I guess, or you can, assume that's what they need, I guess. But again, you have a bunch of right triangles, and then that non-right triangle, what is the best route of attacking it? Okay. All right, great. All right, next problem. Okay, it says, how can you use trigonometry to find the area of triangle ABC? So we're going to learn a new area formula. I know that you know that area, right? The typical area is 1/2 times the base times the height, right? We know that? Okay. Well, let's try to figure out a new formula using some trigonometry. Now, just like the other formulas, law of sines, law of cosines, we're going to draw this altitude, this height down. And again, the idea is all this boils down to right triangle trig, right? So in this picture, B would be my base of this triangle, and H would be my height. All right. But now I wonder if we can, instead of using H, because H was not one of the given letters, I wonder if we can use something else to find an expression for H. And what we're going to do is we're going to use A. We're going to use sine and A. So sine of A equals, so we're in this right triangle here on the left. The opposite side of angle A is H. The hypotenuse is C. I want to get H by itself, so let's multiply both sides by C. So C sine of A equals H, equals your height. And now, we're going to plug in this for your height. We're going to plug in this for your base, and you're going to get a nice little formula for area. Area equals 1/2 BC sine of A. And it kind of flows, right? BC sine of A. This is an area formula we can use when you are given side, angle, side. It is a side, angle, side method of finding the area of a triangle in trigonometry. So let's try one. All right, so it says, what is the area of a triangle FEG? Now, for some reason, they don't put the numbers on the side. So F is 4, so that's 4, and G is 3. So in this problem, we're given angle E, and we're given side F and side G. So we can use the area formula. I know it's not 1/2 A, B, C sine of A, but it's still 1/2 F, G, sine of E. Notice that all three letters are used, right? The two sides, and then the angle in between is the third letter. So we just do 1/2 times 4 times 3 sine of 1/16. And we'll type this in, and I think we'll round to 1 decimal. Okay, so go to Desmos, make sure you're in degree mode, which I am. So we're doing 1/2 times 4 times 3 sine of 1/16. And there we go, 5.39. We're going to round that to 5.4. They were in centimeters, the side lengths, so that's centimeters squared. All right, great. So I'm excited to see how well you problem solve, right? That's one of my main goals as your teacher, is to teach you problem solving. And again, it's about productive struggle. Take a look, try some things. Don't be afraid about being wrong, and ask questions if you have them. All right, we'll see you in class.